So our follow-up lesson on 2.2 for polynomial functions is going to be when I'm given a bunch of data and I want to use my scatter plot feature to figure out like what it really should look like and what type of polynomial function I might be looking at. And we're going to use several of our regression features today to figure out which one is appropriate. So this particular example has an oil tanker that collides with another ship and it's going to be leaking oil at a rate that's shown below in the table. So we're going to create a polynomial function that models the data set, and I'm not really sure what kind yet until I kind of get it graphed. So I'm not sure why there's dots all over my face over here. I guess we'll find out. So we're going to grab our calculator and we're going to enter that data into our calculator. All right, so one of the things you're going to need to do at some point is turn your stat plot on. I'll get to that in a second, but in stat, and then choose edit. I already have some old data in there from another problem, so I'm just going to clear my list out. There's other ways to do this, but I think this is the easiest one. Just go up to the name, hit clear, and then get back down. And then enter your data very carefully because it does have to link up. So like 1, 2, 3, 4, 5. I like when they go sequentially. You and I can do that. Now here you got to be careful. So 18. You might as well just pause the video and shut me up for a minute while I type your thing. Oh. I gotta concentrate. Okay. So my data's in. Hopefully yours is in. If it's not, please pause the video and get your data entered appropriately. So now, what I want to do is I want to turn my scatter plot on and clear out like whatever else is in my calculator. So y equals, get out of there. I need to go up to my plot, but I need to set it up so it's the right type of plot. So open up your stat plot, turn on the first plot, and then make sure that scatter plot is highlighted and make sure that your data is coming from the right lists that are set. So if you put your data in some other list, make sure you change that up. You can change the color and I like to use little squares. It works for me. Now, if I just hit graph, the window's not set up, so I'm going to cheat and hit zoom stat, the best one for scatter plots. Zoom stat, that's nice. Can you kind of tell what that looks like? I think it says in your notes even, it says to use quadratic regression. So that is definitely like a partial portion of an upside down looking quadratic function. So what we're going to do next is we're going to go to stat, and this time over to calc. And we've used linear regression before, but that was only appropriate when it was linear data. This is quadratic regression. Okay? So choose quadratic regression number 5. And then make sure your data's in the right order. Now mine's defaulting to list 2, list 1 for some reason. I'm going to need to change that to list 1, list 2. And then if you want, you can store the regression equation into y1. So if you remember how we pull that up, we go to, let's see, I always forget, under vary, right here, and then go over to y varies, and it's a function, and then put it wherever you want, so y1 works for me. And then when you go to calculate, oh, by the way, I left frequency list empty because I didn't have one. And then it, gives me all that information. It's awesome. It does tell me my correlation coefficient R squared. Let's see. So they want me to write down that equation. you're going to have to truncate and round at some point. It doesn't really say where to round, so let's go like 3 decimal places. Jot that down. And then, other thing, they want us to use the model to estimate the flow rate in 10.5 hours. So remember how we made it store into Y1? That's nice, because now when I go to my table, if I turn my table to ask mode, which it already is, I can just go ahead and type in 10.5. So that's nice. So, pops out 0.17 roughly. And if you look at the labels on here, it's measuring in liters per hour. But it does say somewhere in the table that it's measured per 100. It's in the 100s. So if you take that 0.17 and multiply it by 100, you do get 17 liters per hour. Fascinating. All right, so same issue is going to happen on the next example. Oh, wait, time out. One more follow-up question. It says, use the model and determine what time the flow rate was 1,000 liters per hour. So remember, it's measured in hundreds, so 1,000 would equate to us using 10 for y. And what I would do is I'd go to y equals, and I'd come up with another function, y equals 10, and I'd just figure out where they intersect. So there's that blue line is the curve that's sketching in, and then there's my line 10, and if I found the intersection point, or we do second trace or calc menu, and then choose intersect, and then just hit enter, enter, enter. Apparently it's 8.5 hours. So, works for me. And they don't really tell you like a starting time, it just tells you how many hours have elapsed. So just write down 8.5 hours later. Excellent. Alright, so the next question. Distance from, oh boy, the farther a planet is from the sun, the longer it takes to complete an orbit. Cool. Alright, I did all this already. Use it, and that makes sense because the orbit, you know, the circumference of it is going to be much larger. So using a graphic calculator to write a polynomial function, this time we're going to use a power regression. And once we get the data entered, I think we're going to see that this indeed is one of the power regression looking scatter plots. What I'm going to do is I'm going to pause the video. I'm going to enter the data, you know, under the cloak of privacy, because apparently it takes me an hour and a half to type data. So I'm going to pause. You pause the video as well, because in a few seconds it's going to pick up at us being on our calculator again. So best wishes. Meet you up in a minute. I'm back. So if you're not ready, please pause a little bit longer and then enter the data. I think, fingers crossed, I have it done well. We'll find out. So I'm going to, first I want to do zoom stat, so I can kind of take a peek at what this looks like. I already deleted my old info. So, you know, that does look like a power curve. It's a portion of one of the power functions that we learned about a couple lessons ago. Definitely not the entire thing, but a portion works for me. And it even told me in the directions to use power regression. So, no ifs, ands, or buts about that one. So go over to calc. And we're going to choose kind of far down the list, though. Keep going. Keep going. There we go, power regression. And then I put my data in list 1, list 2. I did not have a frequency list, but I would like it to store in Y1. I thought that was a nice little trick. That way I don't have to type in anything and run the risk of like typing it wrong like I normally do. Kids who have me in class, you know exactly what I'm talking about. So, after a moment, there we go. All right, so yeah, write that down and make sure that your A value goes in the correct spot for the A coefficient. X is going to stay as a variable, and then your power is 1.5. I think you could say 1.501 if you want to keep some more accuracy. And then the correlation coefficient is like awesome. 0.99999. So this is a really good fit for data. If I tried to use a different regression function, like let's say I did cubic regression or something, it might not have fit as well. I don't know, logarithmic definitely would not have fit as well. So you just have to be careful which one you choose. So I don't know if there's any follow-up questions to that. I don't think there was. So if you're curious and you want to see what a lovely fit it was, just hit graph. That's beautiful. Okay, so there's one more example on your notes frankly, I'm just really sick and tired right now. So I'm not going to do it. But you're going to type that data in very carefully because there's a lot of data there. And it tells you in the instructions to use a cubic regression. And if you looked at the scatter plot for the next example, it would make a lot of sense as to why you should use cubic regression. When you go ahead and type it in, you see some very tiny itty bitty coefficients being used there. So watch out. Make sure you count the right number of zeros. And then they want you to predict the energy output when energy input is 800 calories. And pretty fascinating question because it's talking about, food energy produced by farms, input and output. And this is something that, I don't necessarily know that the farmers calculate, but people who work for the farmers and design products and things might have to look at things. So, good question. Try the regression. In the future, when we get to a summative, I might have you look at the scatter plot to determine which regression. But it often will just be given to you as to which type of regression to use. So don't